So I'll just give a quick introduction to Go, I guess, and then you are going to.
Depends on how much time we have left, and depends on since the crowd here is relatively new to Go, we may just pick one very simple project and we just run with it, just walk through, just get at least everyone have a feel of how we use Go sometimes, or at least how we approach things the Go way. So we will see how we'll play by the ear.
Yeah.
See how things go.
I have to apologize up front because I didn't have that much time to prepare, but I'm quite familiar with Go. I've been using it for 4 years, I think, already. AtomX, the company you're all at now, we're online advertising, exchange, and almost all of our backend code is written in Go, so we have Go handling thousands of requests per second, so a lot of experience with it. Okay, I'll just start simple introduction. Who are all familiar with C or C++ or okay, or Java, but it's not. It's more like C. Go is quite a lot like C. Sorry. Wait 1 second.
Oh, cool. My God.
Why is it going to sleep? Okay, whatever. Okay, Go is a lot like C. This is quickly what I'm going through, like functions, variables, pointers, how to call functions, the defer keyword, which is something really typical Go, strings and slices, structures, interfaces, maps, ranges, coroutine, channels, and this is the only basic slide I've prepared for this presentation. I will do everything live coding. If you have any, if it's working. If you have any questions, you can ask immediately, or, well, I can basically, all the questions I can answer by just showing you what the code will do. If only my Firefox was working. Okay. I'll just choose Chrome. I'm one of those guys, I use Firefox as my main browser, and I would say usually that works really well.
Time to switch.
Actually, Chrome crash more often for me. Interesting.
Yeah, I don't know. If I have to develop anything, I always switch to Chrome, but as my main browser, I use Firefox. Okay. Go is written by Google, and it's really built as like a back-end language for simple back-end services. So everything that it comes with, like the standard library, like the way the language works, is all really good for back-end stuff, like building services, building servers. It's all quite well thought out. One of the nice things about Go is that you have the playground, which is basically just like one script you can run, and it actually executes your Go code and prints the output, and you can share those scripts. So usually with Go, the way people share stuff is through the playground. And today I'm going to use the playground as well for all the demos. Go source later will get into packages. For now, the most important thing is Go, you have a package main, which is basically the package that gets executed if you build an executable. It has a main function, just like Java, C, or most languages. The main function is the one that gets executed first. You have imports. What did I have next? What is? Yeah, okay, so that's the main function. You can declare variables in Go in different ways. One way is I can say I want a variable x that is of type string. Then I can say x is blah blah. Well, it all looks very familiar. I can print that x, I can run this, print blah blah. Another way that Go has to declare variables is with the colon is syntax. With colon is syntax, it will use the function or variable or whatever it is on the right side of the expression and infer its type from it. So now x will still be a string, but I don't have to tell it it's a string. It will automatically know, like, oh, this is a string. For this, it's really simple and not really that needed. But if you have like all kinds of functions, so now I can assign x the return value of foo, the function foo. I don't have to know what exactly foo returns. It doesn't matter to me right now. I just assign it to this variable that works automatically. In Go, I can also easily do printf instead. This, for example, this will print the type. So I can print int, it will be an integer, just like I said here. Functions in Go are a type declarations in Go for functions are always written a bit differently. So in C you would have int foo, like you would have something like this in C. In Go it's always the other way around. So you first have the function name and then as last the return value. Same for arguments. If I want an argument A that is an integer, I first do in C it would be int A, in Go it's a int. And now I can do something like this. And plus 2, so that will print 4. So in type declarations are always kind of backwards from most languages. Why they choose that, I don't know exactly. But it's actually quite nice. People that are familiar with C will probably know about pointers and stuff. In Go they kept exactly the same, but in Go, so I can say A is not an int, but it's a pointer to an int. Who is not familiar with pointers? Like, I don't know. Okay, I'll quickly explain. So if you have okay, so this now x, okay, so now x, I can make 2, so you have in memory, you have an integer, usually 4 bytes, which contains 2. If I do this, then y also contains that 2. In Go, you can also have pointers, so I can say y is a pointer to x, and that means that y will not contain 2, but it contains a pointer to that memory that contains 2. So I can still print y now. It's gonna print some weird value because apparently this 2 is in memory at location, well, whatever, I don't know how high that is, but, and that might, okay, it's always the same. It might be different, it just depends on where your program is in memory. Now if I want to assign to y, I want to assign it 4, that's not gonna work. It's gonna say, cannot use type 4, which is an integer, and assign it to an integer pointer. What I can do is say I want to assign where y points to. So now where y points to is gonna be 4. So x is 2, y points to x, or the memory that x contains. What y points to, I'm going to assign 4, so x is going to be 4 now. So if I print x here, x is going to be 4. So with pointers, you basically, yeah, they point to something. They are not the exact value, they point to the value. This is exactly the same syntax as you would have in C, so people familiar with C should probably know this. With pointers, it's always a bit risky stuff, because you can have, for example, if I have A, which is an int pointer, and I'm gonna say where A points to, I'm gonna set to 4. So now I can say foo. So this is still gonna work, because now I just call this function, which does the same as the statement I just had now. But if I say y is null, then it's gonna crash. Oh, sorry, nil, it's in Go, it's nil, not null, I don't know why. So now I say it's a pointer, but it doesn't point to anything, it points to nil. And then when I'm going to try to assign 4 to where it points to, well, it doesn't point to anything, so this is gonna compile, but it's gonna crash like invalid memory address or nil pointer. This is called a dereference, so this is a nil pointer dereference. Everything else with pointers is the same as in C. Go has one very nice thing, what I think that C doesn't have. With C, you have a lot of times you return an integer, and then if the integer is negative, it's an error, and if it's positive, it means something. In Go, you can have multiple return values. So I can return 2 integers, for example. The syntax for that is this, sort of a tuple syntax. So now I can say I want to return 2 and 4. I can assign this again. Oh.
Returning 2 values.
Yeah. So if I assign the return, because this returns 2 values, I also have to assign it to 2 variables, and then I can do something with those variables. Oh yeah, the %v is just a simple Go thing for print whatever value it is. So in C or other languages, you would probably have to do like D for an integer, or F for a float, or S for a string. In Go, you can just do V and it will print whatever it is, whatever the value is. Very useful. So I can return multiple values at the same time. So I can do a boolean and an integer, and for example, I can return like the first variable the first thing that I return, I can make a boolean and indicate if it was an error or not. For this Go, usually the convention is actually to use the error type. Error is like a built-in type in Go. So usually you will see code like this, like if a is 2, then it's fine. I will return a times let's and then nil. So error can also be nil. Error is like a special built-in thingy. Otherwise, I return 0 and I construct a new error object.
So you're essentially passing exceptions.
Yeah, it's sort of, Go has exceptions. I'll get into that later. Well, not really exceptions, but something comparable, but it's not really meant for exceptions. So in Go, it's usually normal for functions that can go wrong to always return what they're supposed to return and an error. And then in Go, you always have code like X error is foo, and then if the error is not nil, then I want to do something with that. And that error. Else, I just print my return value. Sorry,
Yeah, because
if I do 2 here, that's going to be fine. So if I do 2 here, then error is going to be nil. So it's going into the else clause. So it's going to print my value. If I do like a 3 here or something, then it's going to go into this path, and it's going to return 0 and an error, and it's going to print that error. Again, like the %v, I can also print the error, and it will just take the string out of it. So this is quite normal code for Go. Another way I can format it, which is like really Go specific, is I can write it like this. You see that more often. So if I do it like this, like I assign something in the if statement, and then dot comma and or semicolon, where you want to call it, and then I have this. The scoping of that is a bit different. So now if I want to do x is 2, this is not going to work because it's going to say x is undefined here. It doesn't know about x. Oh, I cannot. If I do this, and then x is 2, that's going to be fine because now x is in the outer scope. So if you do that other syntax, if you do this syntax with this, then the x and the error, the scope of those variables will be inside the if and else blocks. So Go doesn't have, if you're familiar with JavaScript, where like usually if you have a variable, it's like scoped to everything inside that function. In Go, you really have scoping per block. So also if I assign a variable in here and I want to do something with it here, that's not going to work. It's going to say y is undefined. Another thing as well about Go, this also doesn't compile, because in Go you don't have warnings, you only have errors. So now it's going to give an error, y declared and not used, because I'm declaring y but I'm not using it. So in Go, what in other languages would probably be an error, like I don't know any other language where this would be an error. It's all, most languages will be like, okay, fine, whatever you want. In Go, it's really an error. A lot of people complain about that. I personally think it's really good, because in normal code, like you never really have that much of an overview. You know, okay, you have see your warnings, then you can see like, oh, they are not using this variable. I like that in Go it's just like, no, you're not allowed to compile that. You have to clean up your code and make it nice. Same goes for imports. If I import the strings package here and remove this, I try to compile it. It says you imported something you didn't use, so no, I'm not gonna compile. Very good, because myself, I write Go in Vim, and I don't use any plugins, so I really prefer if Go tells me about like unused stuff and whatever, because I don't use a fancy editor to tell me that stuff. What you can do if you're writing code in Go and you're like in the middle of writing something, you want to test it, and it gives you this error because you already wrote some complex code to do this, but you're not using it yet, then you can always assign something to the underscore, which is basically like /-/null or just like nothing. So if I assign it to underscore, then it's not going to complain, then it's going to run fine. But I cannot use the underscore for anything. I cannot do like x is underscore now. I've actually never tested that, but I'm pretty sure, yeah, okay. See, you can only use underscore as like black hole.
Is that its only function?
Yeah, that's basically its only function. So in a lot of cases you see, okay, if you don't really care about what error it's going to return, you usually see something like this, where you just assign the error to the underscore if you don't care about it. Then one really specific thing in Go, which is the defer keyword, which is like this. In Go, you can call a function like this, but you can also use defer. How am I going to show this? I don't know.
Open a file.
Simulate the file open.
Yeah, okay, but the problem with the sandbox is that you don't really have a file system.
How about, can you sleep? It's deferred execution, right?
Buffer open.
Yeah, I'll just, okay.
It's just some random stuff, yeah.
Buffer IO.
I'm just going to do it differently. Okay. Alright. In Go, that's also very important. In Go, functions are first order values, it's called, right? First class values,
Yep.
sorry. For the people who don't know what first class values are, it means a function in Go is also a value. So I can also say x is a closure, basically, or maybe easier if I do. sufficient. I can say X is full. I print the type and I print the value X. So I can actually assign a function to something. So a function is a value, just like an integer or a string or anything else. And you see now X is of type func, and well, this is the memory address of that function. If I do an integer as argument and the string as argument, then it's gonna be of type of this specific thing. Defer is a keyword that accepts a function, so I can I can also write a closure. So this is would be a closure. So I can write X is this function, and this function is going to be
Now put in
now X defer X. I can call X. Let's show that first. So I can do
You will do
this.
the same.
About closures, might as well explain this as well. I can say A is a 2, for example, and I print A here.
Yeah.
So now this function is a closure, which, because it's defined in this scope, it still has access to A. So I can do A is 2 now, but I can also do A is 3, X, A is 4, 4X again. So now you see 3, 4, because this A is really this A. But the defer keyword, that's where we were going. Defer is a construct in Go. I can show you. Defer, you give it like something it needs to execute, and it will execute it when the current scope or the current function returns. So what this is going to do is going to say like, okay, queue up X for execution, but don't execute it yet. Then it's going to print out this because I tell it. Then the function returns, so it's going to print X. So if I do this, it's going to do bar first, and then it executes the deferred foo. This is usually very useful for
No chairs, so I think this
example,
coming first,
for
I'll define
this
some.
kind of stuff. You usually have, if you want to work with files, it works usually something like this. I open some file. I have no idea if I have any file access in the sandbox. Then you usually do like if error, whatever, something with error. I'm just going to ignore the error for now, and then you defer f.close. And now I'm going to do like all kinds of stuff with the file here. I do f.read, whatever. I can do just some pseudocode. I can do like if error is some bytes, some error. I read some stuff from this file. If there is an error, I'm going to like maybe this function returns an error. I'm going to return that error. Otherwise, I don't know. I read some more, just some pseudocode. So now, whatever happens in this code, wherever I return, always f.close will be called. So I combine my fopen, my OS open and my fclose together. So instead, in a language like C or some other languages, you would have to do like, okay, here I need to close it before I return, here I need to close it before I return, here I need to close it before I return. In Go, that's made much easier by just saying, just when the function ends, I want to close it.
So this can work for, let's say, socket.
Yeah, for or you use it for all kinds of things. Basically, if you have something that needs to be closed or that needs to be handled in some way, a lot of things. What I always do, if we have the time package, I will do start is time now. I'm going to do some heavy work. I zero, I extend, I don't know, lots. I don't know, nothing. Just some bullshit. And I'm going to do defer function. Let's start. So what this is going to do, it records time, not the time packaging goes like timing stuff. So it reports the time that my function starts, and I defer, like for when it exits, I want to execute this code. What that's going to do, it's going to print the current time minus my start time. In Go, when you subtract two times from each other, you get a duration. The duration has like some nice pretty print stuff. So this is going to do, sorry. This is going to do, well, 0 seconds, because it's fast. I can also do in Go time.sleep, time.second. I don't know, I want to sleep 2 seconds. So now it's going to print after 2 seconds up my function to 2 seconds. So this is really useful if you want to time something, see how long it takes.
Question. Is the defer func at the end there, the 2 parentheses, does that indicate?
This, yeah, because you always need to call something, like the defer statement needs something to call. So if I do this, then then now I'm just passing a function to defer. Yeah, I agree, it's a bit weird.
Yeah.
You're immediately invoking the function.
It's immediately invoking the function. Is that
No,
what that
it's
is?
more like
or-
It's an
It's
IIT.
it's a closure for the
no.
function. It's a closure for the functions.
Yeah.
Yeah,
Because-
actually,
because you don't have
this
the
would be a
variables.
closure for the function. This would be a closure for the function, but you have to
Invoke it.
invocate it,
Yeah.
and actually the arguments for the invocation are already like well, how's it called, like in the I can't come
The
up
first
with the word now.
parenthesis is defined, the other one is actually
Okay,
Yeah,
I'll show you this.
I mean,
Yep.
I
do this all the time in JavaScript.
Yeah.
It's similar to Python context
Lambda.
manager, but less verbose.
Yeah, put it this way, this is like
No,
lambda
but
class.
Yeah.
of-
No, I mean the defer.
I agree with your question. It is a bit weird.
So in Python you have to define the start and the enter and exit.
But it's the same format as if you want to call a Go routine though.
Yeah.
So, but it's just that normally in defer, you don't really define a function that takes parameters, because defer in this case is that yeah, you don't.
So it is actually a bit weird. So the argument here, I'm passing a. Maybe I should make it a bit clearer.
Yeah.
This B. Okay, so now my closure has an argument. Here I have 2. I pass that argument. That is already evaluated the moment I do this. So that A is 3 is not gonna go into this closure because it's gonna get 2. But yeah, I would agree it's a bit weird, but that's because sometimes you want to defer something that you have to pass an argument to, so that's why they made it so you have to. So actually, like, this is evaluated now, but the execution of the event function is evaluated at the end.
Let's do this experiment. Within the function, defer function, get time dot now. Outside the function, do another time dot now.
Okay, remember one thing is that we are running this in the Go playground. Go playground actually has a fixed timer, so it's
Yeah.
actually a fake time. So
Okay,
you
so-
may not work the
so
way you
that's
think
not-
you will work
but
in the
yeah.
Go playground.
I hope that makes it a bit clear. Like, yeah, you have to use these parentheses because you can sometimes pass. Like, I could also have
So does
code
this
like
mean that
this.
values you're passing into a function are copied into a different memory location when you pass into the function?
Yeah, this
So
here,
how does this
here
work?
A is
Yeah.
copied into a different because it's B. If I want to have this B be the same as A, I would have to make it like
A
a
pointer.
pointer, yeah.
Yep.
Right. So I can have
So we change the pointer there if the latest value.
Right, so if you pass in a pointer to A instead, then it would still be 3.
so I can also have this where I don't write the code in my block here, but I just do like this. So sometimes you don't have like the code for the function that you want to defer in there, and then you don't have a closure with that scope, so you have to pass it an argument for somehow, then you use it like that. So this is still gonna print 2. And you can have multiple defer statements, so I can do for bar A again, and now it's gonna print 2, and then actually, defer, I have to explain as well, defer statements are executed in reverse order that they are executed in your function. So this is gonna first execute this one, which is gonna print 3, and then execute this one, which is gonna print 2.
So that's why you put the F close at the top, because if you want to do further defers,
Yeah.
they would be down and they would be executed.
Yeah, so
before.
defers are done in reverse order. So if you open multiple resources or stuff, they're closed in the reverse order how you open them.
What if A is a pointer instead?
If you want to make this a pointer instead, I can do that, and I have to say defer this pointer. I do NA. Now this
Can
D,
you remove the second default?
then it's, what is it gonna print? What does everyone think?
Ah.
No, it's gonna print 3. So now my bar function takes a pointer to an integer. Here I assign an integer to 2. I give my bar function a pointer to this integer. Then I assign 3 to it, but the pointer is still to the same integer, so it's still the same. So this is gonna print 3.
So defer is like a finally in Java.
Yeah, the first, yeah, it's definitely, I
So
think
is there a
exactly
defer
the
block?
same.
Is there a defer block?
Well, what I just wrote is like if you do it like this, that's sort of a defer block. If you write it like this.
Syntactically similar.
Yeah. Oh, one other thing that's really nice about Go, by the way, that I completely missed in the start. If I write like super ugly code, like really ugly code, in Go has a formatter built in the tool, so if I press format, it's going to format it exactly the way, I don't know why it does this empty line, but it's gonna format exactly in one preferred way, and everyone that writes Go is supposed to use that formatter and format the code exactly the same. So there's no choice like, no, I want my brackets here, and I want, I don't know, if I have like a long variable name, then I want to do it like this,
Oh,
like,
God.
nope, Go. Yeah, or even complains if I put the bracket on the next line, okay, whatever. Okay, but if I want this, like, oh, I prefer it like this, I would personally actually prefer it like this, I think that's cleaner. But no, Go format says like, nope, always only one space after it. The nice thing about that, if you get used to this syntax, everyone online uses it. So any package you find online, any Go code you find online is usually formatted exactly the same way, which makes it really easy to understand.
Just use indentation.
Yeah.
But does it run if you don't run it?
Hmm?
But does it run if you don't format it?
Yeah, it runs if you don't format it. So there are people who just don't format their code and just use whatever they want to use, but I think like 99% of the online Go code is all formatted exactly the same.
So, but we still can write obfuscated code, right?
Yeah,
Cool.
you can, but then if I paste it in here and I press
type
format,
format,
it's
yeah.
gonna make it exactly nice again. So, yeah. Okay, strings and slices. Well, you guys already saw just now what strings are like in Go. So, strings are like blah. I can concatenate to a string. I can print them. Let's go to foobar. And in Go you have slices, which in other languages would be arrays. In Go you also have arrays, but I'll skip that for now. You have slices, so I would say I wanted a slice of integers. 1, 2, 3, 4, 5. Oh yeah, in Go the syntax is in, if I say, maybe this is clear, In many languages, you would do like I want an integer array, like I think in Python it's something like that. I don't know.
You don't need
Python, you,
Python.
don't, you just use
Yeah.
it.
Okay.
It's that
In
tight.
in C it would be like this. You want an integer array. In Go, it's the other way around. You say I want an array of integers. Later, I'll show you that it's, or I can show you now. It's actually quite nice. Later I'll show you why that's nice. So array of integers. So here I'm saying A is an array of integers with a slice. It's called with 6 elements. If I print that, it's gonna do like an array with 6 elements. Now I can actually say, and this is really Python-like, I can say give me from 0 to 2, right? So if I pick B, that's only going to be 1 and 2. I can even omit the 0 if I don't do anything there. It's the same as 0, so this is also going to print 1, 2. I can also say start at 2 all the way until the end. Here, omitting the end value is quite useful. If you don't want to, you can write it like this, all the way until the length, I think, or does it need to be length plus 1? No, it needs to be length.
Yep.
Oh yeah, len is a built-in keyword for taking the length of a slice. So I can write it like this, but this is a bit much, so I can just omit this value, and this says, okay, B should be the values from A all the way from 2 until the end, so this is gonna bring that.
In this case,
Now-
B is a new array, right? It's copying all the values over into it.
No, in Go.
That is the biggest
Okay,
difference.
In the back end,
Yes.
this is actually an array in memory,
Okay.
but the slice is a pointer to the array. So now if I can show,
Right, so it's okay, I see.
if I print A again, and I'm gonna say B0 is 8, so B0, well, B started at 2, so this is gonna be, this is gonna turn into 8, so this is gonna print like 1, 2, 8, or
Right.
show. Okay, this is sometimes a bit annoying. Oh, so actually if I press run, it's going to submit the code to the Google servers, it's gonna run there and transmit the result back here. So the Go playground doesn't work if you're offline, but you can run a local version if you want. I didn't do that right now, so that's why it took a while now. Okay, so this is a new slice, B is a new slice, but the slice points to the same array that A points to.
Can we do negative indexing?
No,
Okay.
too bad. That's what I think really sucks as well. I would also like something like this where you go
Just go
two
pick up the
from
last
two,
item.
yeah, 2 from the end. But
Yeah.
no, then if you want to write that, you have to do like this.
Yep.
And now you're gonna see again if I formatted it, thinks like, oh, this is nicer, whatever. You can also take only one, I showed that here. In Go, a slice and an array actually have it has a length. So this is gonna print 6. But it also has a capacity. It's also gonna print 6 now. But if I do A is append is another built-in function to add stuff to a slice. So I can say A is, I want to append 7 to it. Then if I print A, it's gonna have the 7 there as well. Now if I print the capacity of A, it's gonna print 12. So this array was 6 long. I append something to it, then Go is gonna say, okay, but probably in the future you might want to append again to it. So it's gonna double the array, the array in the back end. So it's gonna double it, copy over this into it, but it only, the length is still 7. So it's only gonna, the slice only uses 7 elements of that array that's now 12 long. It's just a small optimization that if you keep appending and appending stuff, then it doesn't like each time have to relocate the array, each time increase the size now, because now if I append another thing to it, so now the length is going to be 8, but the capacity is still going to be 12 because, well, we already had enough capacity to put that 8 at the end. It's a small internal detail here. It's good to know, but it's not that necessary. You don't, if you're not trying to write really performance stuff, you don't really care about it usually.
Yeah, but these are the sort of features that actually make Go for certain things a little bit faster than your native implementation, like for instance in Python, when every part of your append would actually trigger like, I'm not sure, does it, when you, okay, if we append to a list in Python, you just need to allocate, right? You don't need to copy. But if you do a slice of, let's say a subset of an array, what do you call that in Python?
It's really called slicing.
Slicing. If you slice an array, does it make a copy?
Yeah, it's actually a copy.
Okay, so one of the big differences is that even though it's called slices in Python, in Go, when you slice an array or another slice, it does not make a copy.
Yeah. But this is important. If I do this B again, and I start at whatever, I can do this, like
Yep.
B is a slice that's exactly the same. If now I do B0 is 12, whatever. So now we have A is this array of 6 numbers, B is a slice that points to the exact same array. Now I assign A, I append 7 to the A, then Go is gonna say, wait, there's not enough space here for that 7. It copies, it makes a new array of 12 elements, it copies 1 to 6 to that new array, and returns a slice that points to the new array. But B is still pointing to that old array. So if I run this, this, that 12 is not going to be in here. That 12 is in the old array. It's not in the new array. So that's a bit
Yeah.
some gotcha code that you have to be careful with. So append, if there's not enough space, it actually makes a whole new copy of your array that's bigger and returns you that. So that's why I also always assign here. Otherwise, if I don't assign this, then I append something, but I don't do anything with the return value. And well, one thing that Go doesn't have that I always think is annoying is something to delete something from an array. So let's say I want to delete element 3 here, then I actually have to write this. There's multiple ways to do it, but usually you do this. A is append, I start at 0, I go to element 3, and then I append everything from element, I think until 2.
Yeah.
Now I'm always off with my ones. Let's
Yep.
see.
Off by 1.
And this needs to be 2. Okay, so if I want to delete this element, then it's gonna be really weird. I'm gonna append, so I take the start, so the 1, 2. I take the last 3 elements, the 4, 5, and 6, and I append those 2 together. What this ... does is the same as writing as this. 4, 5. So I can also write this. It's going to be exactly the same, but the ... just unpacks or I don't know how you want to call it.
Can you use 3:len A or something? Like len
Here?
A
Yeah.
minus 1 or something since you're making one less, right?
It would be
No,
the same.
'cause this is the index into the old A, so
Oh,
that's still
so it
going
goes
to
to the end.
So yeah, that's exactly the
it's-
same.
yeah.
So len A and not writing anything is exactly the same.
Yeah.
So this is the way you delete an element from a slice. You just append the part before and the part after together into a new slice. This doesn't make a new copy. This still uses, if we use that B thing again, B is a completely, B0 is 12.
Colon.
Now it's going to be 12. So this append operation, because it has enough space, because we're only removing, the result of this is smaller than 6 elements. It doesn't have to get a new array. It's a bit complex, but that's the way you delete something. I can also, if I have b is an integer 9, so I could also have append a and b together. It also works if I append 2 slices in such a way together. Strings are sort of also slices, so if I have a is a string bar, then I can also use that same trick where I say take everything from position 3 and onwards.